Hi friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 113, pass sum 2. In this video, we're going to share a solution based on tree traversal. So here I'm going to use iterative depth first search. So first, we'll read through the statement to digest the requirement, and then we do a simple analysis, and finally we share the simple code. First, let's look at the statement. So given the root of a binary tree and an integer called target sum, so return all root to leaf paths where the sum of the node values in the path equals target sum. Each path should be returned as a list of the node values, not node references. So the second paragraph actually explains what's a root to leaf path. So here are two examples. So example 2 are 3 examples, and example 2 and 3 are sort of special. For example, in example 3, so we have root with values, the tree with 2 nodes, values are 1 and 2. The target sum is 0. So for sure, in this case, no path satisfies the target and the sum condition. So the return is an empty list. So in example 2, similar situation. So the two node root to leaf paths had sum 3 and 4 respectively, so the return is also an empty list. So in example 1, so there are two paths of root to leaf paths, so the sums are both 22. So here is one marked in blue, and here this is another one. So that's the problem statement and the examples. So the additional assumptions or constraints on this problem are the following. First, the number of nodes in the tree is in the range 0 and 5000. So it means that the tree can be an empty tree or null tree. So the node values are bounded by absolute value by 1000. Similarly for the target sum. So the number of nodes actually determines the problem size, and the node value and target value basically gives the range for the root to path sum. So with that said, let's look at the method. So the method actually is sort of routine. So here we're going to do a depth first, and in between we write some problem logic. So here the idea is actually straightforward. So during the traversal, we store the node and root to node path value list. Then if a node is a leaf node, then we can check if the path sum matches the given target. If so, we are going to append the path value list to the result according to the problem requirement. So here is a notice. So actually the path sum is computed only when we meet leaf nodes. So here is a remark before we write the code. So this problem actually can be solved by a number of ways. So here we are going to use DFS in iterative format to do a verbose implementation. So one could do some further tweaks. For example, we can also include path to node value sum in the stack we're going to use. But that's just a very small improvement. So with that said, let's look at the code. So first, I'm going to treat a special case. So if not root, so this corresponding to the constraint that the number node can be 0. So I'm going to return empty. So actually this special case can be observed in the general logic, but let's treat it first. So then I'm going to initialize a result variable. So this is an empty list at the very beginning. So we're going to return the final state of this variable after we do the depth first search. So for depth first search, we're going to use a stack container. So here, because we have excluded this situation, so at the very beginning, this stack will be not empty. So it's going to store a node and the path, the root to node path value list. So here I'm going to store this root value. So I add a comma here to indicate that this is a list. So let me make some remark here. So here what we are going to install is node and root to node value lists. So this way, when we do the traversal, actually we can check if a node is a leaf node, and then if the path sum match the target sum, right? So then that's basically a while loop for the traversal. So while stack, so we're going to get the node and the path, right? So it's going to be stack pop. And then first thing we are going to do is to check if node is a leaf node. So in other words, if not node left and not node right. So in this case, so this condition checks if the node is a leaf node. If it's a leaf node, so we need to check if sum of the path equals the target sum. If so, we're going to append the current root to leaf path value list to the result. So that is append the path. So this is one situation. In all the other cases, so because if the node is not a leaf, so we are going to consider the left subtree and the right subtree, and then adding the corresponding information to the stack. So I'm going to check if node right. So in other words, if the right subtree is not empty, so we're going to append the stack with the corresponding information. Now the node is node left, node right, and then the path will be path plus. So this plus is list concatenation plus node right value. So this expression is valid because node right is not a null value. So null node, right? So next is to check the left subtree. So I'm going to change the right to left. So with that said, actually we are ready to return the result. So after we exit this while loop, we finished the traversal, and then the state of the result is what we want to return. So with that done, let's first do a special case check. Yeah, it passes one test case. Now let's do a generic case test. Yeah, it passes all the test cases. So let's give a quick summary for this problem before we end. So first, here actually the basis for this problem is tree traversal. So if we are very familiar with the tree traversal algorithms, and then in between writing the problem logic actually is sort of straightforward. In this video, what we shared actually is verbose traversal algorithm. So based on depth first search. So in this way here, actually what we write actually is a special order traversal, right? So you can check my other videos for binary tree traversals, like in order, post order, pre-order, and level order, and so on. So that's about it for this video. Thank you very much.